Now, if we look back to section 4, we'll notice that the column corresponding to Z always was in the form of 0, 0, 0. It was all zeros, and then the very last entry was 1, and that never changed. Well, because that never changes, we can actually just completely leave that column out. And in fact, we're going to be leaving it out from now on. So, at this point, we're going to say goodbye to our good friend Z, at least in the matrix. All right, this section is all about application. So we're going to do a couple of word problems, and really the work is going to be the same beyond the setup that you did in section 4. So a farmer has 110 acres of available land he wishes to plant with a mixture of potatoes, corn, and cabbage. It costs him $400 to produce an acre of potatoes, $160 to produce an acre of corn, and $280 to produce an acre of cabbage. He has a maximum of $20,000 to spend. He can make a profit of $120 per acre of potatoes, $40 per acre of corn, and $60 per acre of cabbage. We need to find out how many acres of each crop he should plant to maximize his profit. And if he maximizes his profit, how much land will remain unplanted and why? So the first thing we're going to do is we're going to set up a table with this given information. So if you want to pause the recording and try it yourself and then resume to check your answer, that might be a good idea. You can kind of do the work along with me. Okay, here's our table. The number of acres will be represented by the variables x1, x2, and x3 for a maximum of 110 acres. We also have the cost per acre with a maximum of $20,000 and then the profit per acre for each of the different crops. Okay, now we're going to take these and we are going to organize them into our objective function and our constraints. Again, if you want to pause it and try to do this on your own and then resume, that wouldn't be a bad idea. And there we go. We have everything all listed. The next thing we're going to do is change our inequalities into equations, putting in slack variables, and convert our objective function into the form we need it to be in to write our matrix. There we go. Actually, the Z should be last. We're going to set up our matrix and pivot. Okay, again, if you want to pause and see if you can do this on your own, go ahead and do that. If not, I'm going to continue. We're going to use the column that has negative 120 as the last entry because that is the most negative number. We are going to divide the ends of the rows by 1 and by 400. And then since 50 is the smaller of the two quotients, that indicates we're going to use 400 as our pivot. We're going to divide row 2 by 400, or since you're doing this in your calculator, what you're going to do is you're going to multiply row 2 by 1 over 400, and that will convert that 400 to 1. And there we have it. The next thing we need to do is to change the first column entries in row 1 and row 3 to 0. In order to do that, we're going to multiply row 2 by negative 1 and add row 1. And we'll multiply 120 by row 1 and add it to row 3. Now remember, you need to write that down on your paper, but you may use your program to do the actual pivoting. When you pivot, you're going to get a matrix that looks like this. Now we are finished pivoting. The way I know that is that there are no negative indicators in that bottom row. You have no negative numbers left in the bottom row, so we're good to go. Remember that what we're going to do is we're going to take our basic variables, which would be the variable in the x1 column and the s1 column, and we're going to have those equal the number at the far right. The non-basic variables, which would be x2, x3, and s2, will all equal 0. And our maximum for Z is 6,000. So we have x1 is 50, x2 0, x3 0, s1 is 60, s2 is 0, and Z is 6,000. So the farmer will make $6,000 if he plants 50 acres of potatoes, and this is the most he can make given the constraints. There will be 60 acres of land left unplanted. That is our slack variable. And the reason that it's going to be unplanted is that there's just simply no money left to plant anything else after planting the 50 acres of potatoes. Solution, looking right here, we see that X1 and X2 are both going to be 0. So glaze and solvent will be 0. X3, which is clay, is a basic variable, and it will be 24. S1 is a basic variable. It is the slack variable representing the number of air pollution units, and that will be 60. And then S2, which is time in the evaporation tank remaining, will be 0. So our optimization, we're going to make a maximum of $9,600. We're going to get that from 24 truckloads of clay. We're at 60 units of air pollution under what we're allowed, and there is no time left in the evaporation tank. And this explains all of that. Okay, now we just have a couple of examples for you to try. Pause the recording, give it a try, and then resume the recording to check your answer. I did include a complete demonstration of how these problems work.